save over here. Put that down, let's see, and then all right. We don't need this. How do we do it? Blah, 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 blah. Yeah. Doing updates. Okay, that's better. I just need it. That's kind of annoying, but that's fine. Okay. So I'll be back to check the attendance for any stragglers. Usually I check it at the 15-minute mark, so that's in like 7 minutes, give or take. Let's see as far as announcements. So I think next week will be the end of the new material. Today we're going to be working on section 4.4. I think we still have sections 4.5 and 4.6. So it's a total of, at this moment in time, there are a total of 3 sections worth of new material that I really want to go through. And then we'll be ready for exam 2, right? Exam 2 is going to be over chapters 3 and chapters 4, right? Whatever we talked about in chapters 3 and 4. Just like exam 1, let me see. So we have this week of material, we have next week, and then the week after next is going to be exam 2. And I think with exam 2, that'll really be the last of the new material that I wanted to talk about. Then we'll have about a couple of weeks remaining, maybe 2 or 3, something like that. And we'll use the remaining time to just review for the final. So I think we have like maybe 4 sessions, 2 weeks, like 4 sessions, I think. So then each day we can cover 1 chapter and review for the final. Okay. Also as a reminder, I just want everyone to be aware of the hard deadline of May 1st. So it's a Sunday night at 11:59 p.m. going into Monday, at the top of the week of finals. All of our assignments of Pearson are going to lock out, right? So with that, you know, if you're going back over Pearson and trying to improve your score, my recommendation, you definitely want your exams to be in order first, right? So approaching that hard deadline, we would have had 2 exams, several quizzes, and a homework. I want to say that the exams, your overall grade, I know it's at least 75%. Whatever's on the syllabus, that's what I intend to do. But I know that your exams are the bulk of your grade, right? So with that, you want to take time and focus and energy to get your exams in order. That takes top priority. Once your 2 exams are where you want them to be, then whatever time and energy you have remaining, you want to go back. You want to work on your quizzes next. I want to say, you know, I limited the quizzes to maybe 5. I think I did like 5 questions per quiz. I just really wanted those to be short. But I know that the quizzes and homework, they're like about 10% of the grade, maybe 7, something like that, but they're a small percentage of your overall grade. So the bulk of your grade comes from the exams, and the intent of the homework was really just to prepare you for the exams, right? So it was really just practice. So I don't really want you wasting too much energy trying to finish all that homework. My recommendation, focus on the exams. Get those in order, because once those are in order, that's the biggest hurdle, right? As always, if you have questions, comments, or concerns about anything, feel free to unmute yourself to get my attention and we can talk about it. I'm trying to think about how to get rid of this sort of thing that's kind of hurting me. And like every time I click on it, it brings me back, which is what I don't want it to do. Not minimize maybe? No, that's not it. Okay, well, I'm not gonna worry about that. So yeah, and you know, hopefully, well, I got to track down and make sure that students still attend, because you know, some guys have been MIA, and that's a dangerous position to be in. Because you know, you can get booted, you can lose out on time and money, and you know, at a minimum, you guys should be checking in. That's exactly why I said that statement about, hey, at least check in, because I know this stuff is intense. Like I know, and I don't know that me being there would make it any easier. But right, you would just have to be dealing with somebody that's more grumpy and silly and this, that, and the other, right? But that doesn't change the material. But I guess, there is some merit about being in person because it's just comforting to be in the presence of another human. Sometimes I don't know if it's comforting being in my presence though. Like I just don't know. But my experience has been that it doesn't really. It's still a challenge. Like it's still a challenge for everybody. So yeah, with that, let's just go ahead and make our way through the material, right? So again, today we're working on section 4.4. So again, at this moment in time, we have a total of 3 sections that we'd like to get through regarding integration, right? For the rest of the semester. Then we just, complete doing our exams, getting assignments in order, and preparing for the final. So again, we have the hard deadline of May 1st. That's a Sunday night going into Monday. That Monday is the start of the week of finals. And so for the entire 5 days for the week of finals, you have access to our final. And you only have access to our final, right? So the idea is that once you're done with our final, you're done with the class. Like you don't have any lingering assignments or things of that nature. So hopefully, we can do what we need to do. I encourage you all to, hopefully you all, I would imagine that you all are still working together. You've sought out the tutors by this point. And it's okay. Just kind of work together and do the best you can. I don't expect you guys to be experts at this stuff. I just want you to get through it and have your own experience, right? So as long as you work and try and push and ask for help and use your resources, it's okay. Like I encourage you. This is again. I don't expect you all to be mathematicians. I just want to expose you to this stuff as best you can. Covering the pertinent, important information, trying to keep it as light as possible. But this stuff it's not easy. That's the simple. It's a simple thing about it. Okay. All right. So with that, we're going to continue chapter 4 on integration. And remember, integration is basically the reverse of differentiation. We take the derivative, we got an answer. Now we're starting with those answers and working backwards and seeing some applications and how to do that, right? So section 4.4, it covers properties of definite integrals, the additive property. Let me see the time. Before I start this, I'm gonna go ahead and check attendance one more again, as they like to say. One more again. I think we're good. So I'm gonna let that be, and don't worry about it. We're gonna hop on into it. I need that to go somewhere. Okay. I think we're good there. I'm gonna let that just do it. Okay. So section 4.4 are properties of definite integrals, right? And so we have the additive property, and then we want to explore this notion of average value and moving averages. A few objectives. We like to use the properties of definite integrals to find the area between curves. We like to solve applied problems involving definite integrals. We like to determine the average value of a function and find the moving average of the function, okay? So we have this theorem 5. So for some A strictly less than B, strictly less than C, let me do the following. No. Okay. So for some A less than B less than C, the integral from A to C, this is what we were doing before, right? And so again, we have some B between A and C, right? So if we consider the integral, which would basically be this whole sheet of region here, if we consider that integral and we have some B that's basically an intermediate between A and C, then basically we can break this integral up into the sum of 2 different integrals. You got this sum, the integral of this first area, and then the integral of the second area, right? So as long as you have a B between A and C, you can break up the original integral into the integral from A to B plus the integral from B to C, right? So again, the integral from A to B, which is this first region, plus the integral from C to B, from B to C, right? Okay. So for any number B between A and C, the integral from A to C is the integral from A to B plus the integral from B to C. Okay. Yeah, let's go like this. So in this example, we're asked to find the area under the graph of f from -4 to 5, right? Where f of x is a piecewise function, it's going to be 9 when x is strictly less than 3. So that's this region here. And then x squared when x is greater than or equal to 3. So this part of the curve here, right? So find the area under the curve, right? So since we have a piecewise function and we want to find the area as x goes from -4 to 5, we can find the area of each independent shape and then add those two areas together, right? So if we focus on from 4 to 3, all right, let's write that out. So find the area. So this is going to be here. So the integral as x goes from -4 to 5 of f of x dx. I know I'm going to need some space. Let me add a page. So that original integral is going to be the same as the integral as x goes from -4 to 3. You can basically just do it 9 dx plus the integral as x goes from 3 to 5 of x squared dx, right? This should get it done. Get her done. Okay. So this is let's crunch these numbers. Okay. So this should be the same as, now the integral of 9 is going to be what? 9x as x goes from -4 to 3 plus, that's going to be what? The integral of x squared is going to be x cubed over 3 as x goes from 3 to 5. Okay, let's go this one. So then the first one, 9 times 3 is what? 27 minus, it's going to be a double, minus a 36, all right? Okay, then we're going to say plus, when x is 5, that's going to be what? 125 over 3 minus 27 over 3, which is what, 9? And that's 9. Okay. So double negative is positive. It's 12 and 13. So 50 plus 13, 63. So 63. 9 over 1, 27 over 3. 100 over 3, 98 over 3. Man, that was 99. Okay. 6 times 3 is what? 180. So 189. So 189 over 3 plus 98 over 3. Let's see. 7, carry the 1, 10, 18, carry the 1, 287 over 3. 10, that's going to be 17, which is an 8. So this is not, okay. So this is going to be the same as, let's see, 9, 27, 17, which is a 5, and 2 thirds. Okay. Let's see, how do we do on this one? Provided I didn't crunch my numbers incorrectly, you know. Of course, we can use calculators and stuff of that nature. I'm just practicing my mental math or just my doing, you know, arithmetic and stuff like that. Let's see, how do we do? 95 and 2 thirds, right? So you see it there. Let me check Zoom really quickly. No, okay. Ugh. All right. So the quick check I usually leave as an exercise for you. So I'm just going to leave that. And, you know, if you want to talk about it, we can. So then we have this theorem 6. Let f and g be continuous functions, and suppose that f of x is greater than or equal to g of x over the closed interval from a to b. Then the area of the region between the two curves. So here's our f, here's our g. So then considering this area in between them, as x goes from a to b is going to be this, right? We have the integral as x goes from a to b and f of x minus g of x dx, right? So this guy here. Okay, so if we want this area, it's going to be this area. Okay. So then find the area of the region that is bound by the graphs of this. So with this, we would look at the graphs, we would graph these two functions, look at them. Hey, come here, come here. Just for the sake of time and simplicity, I'm going to piggyback off the graph. Let's find out where these two graphs intersect, right? We'll pull up the image momentarily, but let's see where these two graphs are equal to each other, because we want to see where do they intersect. So I want to explore where f of x is equal to g of x, just to find those points of intersection. And I think this is space. Okay. So let's look at where we have 2x plus 1. We want to set that equal to x squared plus 1. We just want to see these guys are equal first. We're going to look at their graphs. We can use graphing software. I think I might just do it by hand. That's kind of my mood a little bit. I don't know. I hadn't decided yet. Let's set this whole thing equal to 0. So I'm going to subtract the 2x and the 1. If we move these items to the right, we're going to get x squared minus 2x. If we subtract the 1, I think they cancel, and this is going to equal 0. Right? So I subtracted 2x from both sides. I subtracted 1 from both sides, and we get something like this. So then we can factor out the x, and we get x minus 2, right, equals 0. So then from here, we see that these two graphs are equal when x is 0 and when x is 2. Right, that's where they cross, those different x values. Yeah, we can do a quick graph, it's fine. Let's go to Phifer. I like using dots. So 0 and 2, that's where they cross. So I'll put my origin about like here. Let's do, this would be a positive x direction. The positive y is here. Okay. Let's see. I want this to be 1 here. We'll do 2 here. So that's 1, 2, 3. That's the origin. Let's find the corresponding y's to these guys. For instance, when x is 2, we're at what, 5 in both cases, right? So let me see, 1, 2, 3. I think we can generate some more space. Like this. And then basically, I want everything this like this. That's okay. I'm gonna move this down around there and just reposition this one. Okay. So now let's, because we just basically want to capture y equals 5, right? We got 1, 2, 3, 4, 5. It's a little bit much. Let's reposition it a little bit. Let's go up by 2. I'm gonna move these now. Right here. Okay. All right, I feel like this is better, right? So if we go 1, 2, 3, 4, 5, right? So then if we graph these two, so the first one, the y-intercept is 1. We'll do f in blue. So for instance, when x is 0, y is 1. And let's just go ahead and do when x is 2, all right? When x is 2, I think we said it was 5. And 6, 7, 2 and 5 is here. Right? Let's go for 2. Okay, let's go. Nope, something's wrong. When x is 0, y is 1. When x is 2, we're at 5. Okay, I think that's fine. Okay, so that's the graph. That's the graph of f. And then G will do it in green. So for instance, when x is 0, we're at 1 still. So we still have this point. And then when x is 5, or when x is 2, we're still at here. Let's do a few more points. When x is 1, we're at 2. Okay. So then we get an image like this. Right? It's that, right? Something like that. So we want to find the area of the region between the two, just to kind of be consistent with the text. We're going like tonight. It's a good snap. Can you do a polygon? Kind of. I think I can get it to work. Almost. No, no, I don't like that. Anyway. We're basically talking about this region here. Okay. And let me do this really quickly. Partial. This is better. That is good. Okay. All right, so we're talking about the shaded region. So I think the blue, this was our f of x. The green is our g of x. All right. So notice that if we're evaluating it, if we want the area between the two, we're looking at it as x goes from 0 to 2. Notice that f of x is above g of x. It's when x is between 0 and 2, right? So that means we're going to say f of x minus g of x, right? The top minus the bottom. Okay, because if you're thinking about the y's, you kind of want to finish with a positive result. So basically, we're going to do the following. So the area of the shaded region is going to be the integral as x travels from 0 to, what is that, 2 of basically f of x minus g of x. Okay, dx, right? That's all that we're doing. Okay, so then this is going to be the integral as x goes from 0 to 2. F of x is what? 2x plus 1. And then g of x is x squared plus 1. Dx, right? And let's just do like this. Let's do this. Okay. So then if we simplify, we keep going. Integral as x goes from 0 to 2. This is going to become 2x plus 1 minus x squared minus 1 dx. Okay. We can combine like terms. These guys cancel. We'll leave it as 2x minus x squared, right, dx. Okay. So then when we take the integral, that's going to be what, 2x squared over 2. So that's going to be x squared minus x cubed over 3, because x goes from 0 to 2. So then when you plug in 2, you're going to get 4 minus 8 over 3. So we're going to say minus, oh, then the other one is 0, so we don't have to do the other one. 4 over 1 is 12 over 3, so this is going to be 12 over 3 minus 8 over 3, which is 4/3. That was an adventure. Let's copy. Okay, that's what we got. Let's do like this. Let's go to paper, remove the lines. Done. All right, so we got 4/3 from this, right? So find the area of the region that's bounded by, so we have a digital version, right? You see that f of x is greater than or equal to g of x on the interval in question, right? So we looked at the graph. We found the points of intersection. So when x is 0 and 2, you see the 4/3 in the bottom right here. Let me check. Okay, let me get the student. Ooh. Ooh, good. Edit. Make sure I got it. All right. All right. So continuing on. So yeah, that one was fun. All right. So if you're just joining us, let me see. So we're working on section 4.4, properties of definite integrals, the additive property, average values, moving in averages. As usual, we are live streaming this to YouTube, so you can always go back and see the things that we missed. So now we're going to get started on example 3. Right? We have a clever college student develops an engine that is believed to meet all state standards for emission control. The new engine's rate of emission is given by this equation that you see in the center. Right? Where EFT is the emissions in billions of pollution particles per year at time t in years. The emission rate of a conventional engine is given by this. Okay. So we have the student's engine versus the conventional engine. It says the graph of both curves is shown to the right. This is a conventional engine. This is the student's engine. At what point in time will the emission rates be the same? So they want us to find this point of intersection here. And then what is the reduction in emission resulting from using the student's engine? This is the conventional, this is the student. So then basically it's asking for the area between the curve. So we're gonna, let's find this point of intersection. Let's see where these two are equal to each other. So let me see, we want to see, let me just screenshot these. I want to take it from here to there. I really just want to do it. And let's add a page. Let's take that and drop it here. Come on. Let's copy, paste, and then let's crop. And this is the first one. And crop, and here's the second. Crop. Okay. All right. right, so the part A, it asks, oh, crop a little bit more. It asks, thank you, stop. At what point in time will the emission rates be the same, right? So for part A, basically it's just asking us to say, okay, when will E of t be equal to C of t, right? So then on the left, we're gonna have 2t squared, that is 9 plus t squared. We can set this entire system equal to 0, right? So I'm gonna move everything to the left. If I subtract t squared, on the left, we're gonna have t squared minus 9 equals 0. You just want to factor this, or its factors, we can factor it into something of this form, where we have t and t is a plus and a minus. I think it's 3 and 3, right? Difference of squares, okay? So then from here, we get that t equals plus or minus 3. I think that's hours, but in this context, the negative doesn't make sense. So we're just gonna go with t equals 3, just because of the context of the question, right? So these are gonna be the same when t equals 3 years. That is part A. Let's copy. And then for part B, it says, what is the reduction in emissions resulting from using the student's engine? So what they're asking, they're asking for the area of the shaded region. So we're going to use integration to find that area. So then for part B, we're going to say the x for the integral as t goes from 0 to 3 of, we're going to say c of t minus e of t. So we're going to say c of t minus e of t. And we're going to say dt. Switch out my headphones really quickly. Let's let that kind of ride until I hear it ping again. So if we keep going, c of t, so we're going to have the integral as t goes from 0 to 3. C of t is what? 9 plus t squared. So we're going to say minus 2t squared dt. Right? So then if we keep going, combine like terms and simplify. T minus 2 is a 9 minus t squared. dt, okay. So then now we're ready to integrate. So when we take the integral, that's going to give us 9t minus t cubed over 3 as t goes from 0 to 3. So then now we plug in when t is 3. That's going to be 27 minus 9. And then when t is 0, I think it's just going to be minus 0. 2 more is what, 18? Let's see. Billions of pollution particles per year. So then this will be 18 billion pollution particles per year. So it reduces it by, I'm going to say 18 billion pollution particles per year. I think that's it. Let's copy, paste. Let's see how do we do, all right? Let's just check. Okay, so since negative time has no meaning in this problem, the emission rates will be the same when the time is 3 years. So we got that one. You see the 18 billion pollution particles per year, right? So I think they did the same thing that we did. Let me check Zoom really quickly just to see if you guys. Okay. Let's see. Are we able to go on homework? Yeah, we will be. Yeah, let's just finish this up and then we can go. Okay. Okay, so we got that one. Let's see. So now we have a definition. So let f be a continuous function over a closed interval from a to b. Say the average value y average over the closed interval a b is given by the average y value, or the average value is going to be 1 over b minus a times the integral as x goes from a to b of f of x dx. Okay, the integral is giving us the area, and then if we want the average, we did 1 over b minus a. Okay, that's fine. So that's for average value. Oh no, I guess I didn't prep this slide. Let me find the average value of this over this. Okay. Let me do this. Let's copy. Okay. I just be missing slides. Okay. Find the average value. Let me copy and paste. Suppress. Copy this. Let's copy. And just for sake of simplicity, can I copy like a flattened copy of this? Copy the background. Let me just add a slide. No. Can I create a page? No, that's not what I want. Nope, that's not the thing. Come on. We do. Okay. There you go. So what I can do, I know what I can do. Let me do this image. We can just do this in here. I'm just trying to get something that doesn't have all these extra parts in the back because sometimes those get blank. So what I'm going to do, I have a blank slide here. Let's copy this guy, copy. And here. Let's paste. And then let's delete this one. Actually, let me take this. Right there. I'm gonna delete this one. Okay, there we go. That's essentially what I wanted. Okay, so find the average value of this. Over 0 to 2. Okay, so for average value, we literally just said, so then like y average, the average value is going to be 1 over b minus a times the integral as x goes from a to b of f of x dx, right? That's what we just said on the previous slide. So then if we take that, so then our average value should be 1 over as x goes from 0 to 2. So we're going to say basically it's 2 minus 0 as times the integral as x goes from 0 to 2 of x squared dx. I just plugged it directly into the formula from the previous slide. Hopefully you guys can still hear me. Sometimes, when you like switch out the earbuds, it kind of disrupts and breaks whatever, but I think it's okay. Okay, so I think we got past the hardest part. So then this is going to be 1/2. The integral is going to be x cubed over 3 as x goes from 0 to 2. And you can just multiply the final answer by 1/2. So when x is 2, that's going to be, I think we got what, 8 over 3 minus 0. So then 8 divided by 2 is what, 4? 4/3. Did we just do this? Let's copy. Let's see, how do we do? 4/3 or 1 1/3, right? So you see the curve, right? Y equals x squared. Then we consider the area under the curve, and the average value is, it's a central tendency, right? So the average value is here. We got 4/3. Okay. So then Rico's speed in miles per hour, t minutes after entering the freeway is given by this guy. From 5 minutes after entering the freeway to 25 minutes, what was Rico's average speed? So average value is what we just talked about. How far did he travel over that time? Let's first find his average speed, right? And let's go to space, add a page. Okay, and let's go ahead and get a copy. Oops. This formula. Okay, we can go from here. That's fine. So we'll reference this guy. Okay. So think about it. His average speed should be 1 over, it said from what, 5 to 25 minutes, right? So it should be 1 over 25 minus 5 times the integral as t goes from 5 to 25. I'm just plugging it into the formula of v of t, of all of that, right? So it's kind of nasty. So we got this negative 1 over 200 t cubed plus 3 over 20 t squared minus 3 over 8 t plus 60 dt. Okay. So then this is going to be 1 over 20. Let's go ahead and find the integral. So t cubed over 3 becomes t to the 4. So
Yeah,
we're gonna have
Professor,
minus.
we can't see the screen.
Okay. Let's see. Here. Screen share. I knew something. I got booted. I wasn't sure what it was. Okay. So now let's see. So it's going to be t to the 4 over 4. So t to the 4 times 2 is 800. So t to the 4 over 800. That's going to be t cubed over 3. So plus t cubed over 20. Because if you have 3 over 20 times t cubed over 3, the 3's cancel, we get this. Okay, let's keep going. The next one's going to be t squared over 2. So then it's going to be minus 3t over 16. And then plus 60t. And we want to evaluate it as t goes from 5 to 25. Okay. Man, I'm probably just going to use the calculator for all of that. You think? Because those numbers get kind of ridiculous. Okay. So I'm just going to use a calculator for this. Let me at least go ahead and write it out. So then this is going to be 1/20 times, basically we're going to have a negative 25 to the power 4 over 800 plus, and let's do like this, 25 cubed over 20 minus, what is that, 75 over 16. Well, if you had 6 quarters, that's what, 150, so 1500. Let's just leave it as 60 times 25. Okay. And then we got to say minus the same thing, but with a 5. All right. So we're going to have negative 5 to the power 4 over 800 plus 625. Let's just put 625. And then 125 over 20. Yeah. Minus 15 over 16. 300. All right. Okay. All right. So that's what I want to put in my calculator. Okay. So then this one was more so just nasty numbers. Like the concepts here, like if you've been okay with integration thus far, this isn't really that bad. It's just the numbers can be kind of messy. You just got to be neat and organized and take your time, write big so you don't confuse yourself. Let me see. So 1/20, right? Got a double open. Let's do a double open parentheses. Now the first one we get is negative 25 to the power, nope, negative 25 to the power 4, okay? Over 800, I feel okay about my use of parentheses. We're gonna say plus 25 cubed over 20. Okay, I think that's okay. Minus 75 over 16 plus 60 times 25. Now that's the first part. Then we're gonna say minus. Now you know what we could do that might be more simple. I mean, there are other ways. Instead of doing this, what I'm going to do, I'm going to use this formula, right? Just in case I'm trying to minimize on the places where we can make a mistake. So what I'm going to do, I'm going to use a formula, 1/20. That's not as, there we go. Then we're going to say parentheses, negative x to the power of 4 divided by 800 plus x to the power of 3 divided by 20 minus 3x divided by 16 plus 60x. Wait a minute. I found a mistake already. We missed the square. See, it's a good thing I went back. We would have got that wrong, and we would have been like, "Oh, we got to find a mistake." Man, right here. I found it already. So right here, this is supposed to be 3t squared right there, right? So that's squared. That means that that's off as well as this one, right? But it's okay. Let's go ahead and fix it. 625 times 3. So this one should have been, because if that's 25 that we're plugging in, 625, right? So then this one should have been 3 times 625. And then I think that's fine. And then this one, this one would have been, we're plugging in a 575, right? 25 times 3 is 75. Okay. Okay. So let's keep putting in this formula. It's just, you just have to take your time, right? All right. Let's see. That's supposed to be 3x squared right there. Right here, it's supposed to be 3x squared. That's not squared. Squared divided by 16. I'm just kind of starting over from this point. Okay. Plus 60 times x. Okay. Let me see. Okay, so I am going to remove that 1/20 because it's basically we're using that part. There's a part that we're using twice. So instead of typing it out twice, I'm just gonna use it as a function, right? Okay, so let's see it in action. So then now to crunch the number, we're gonna do parentheses 1/20, and then let's do another set of parentheses. We want to do when x is what, 25. We want to basically plug 25 into that function. So we're going to call on that function like we've done. If you need me to go through these details, let me know. So basically when x is 25, and then we're going to say minus, calling that function again, when x is 5, right? And then close parentheses, right? So basically that part, that t to the 4, t cubed, all that, I wrote that as a function. And then I said 1/20 times that function evaluated at 25 minus that function evaluated when x is 5. Okay, hopefully we caught all our mistakes. The average value, okay, we got something, 68.75. Okay. So now we got 68.75. Let's see if we can have some context. These little, come on. So the velocity, right? So the speed, so his average speed was 68.75. That's a reasonable answer. Miles per hour. Wait. Miles per hour is given by this. Wait a minute. Yeah, I think this is fine, all right? So his average speed from 5 minutes to 25 minutes was this. And we're gonna say miles per hour. I think this is okay. Miles per hour. This is a reasonable answer. Just gonna kind of go with it. Let's copy. So then the second part, how far did he travel over this time? So this is what, 20 minutes? So we need to convert minutes to hours. So if we want the distance, right? So then for the second part, we can say this 68.75, again, the units here are miles per hour. We want to convert this to miles, right? So we're gonna say times. So now he traveled for 20 minutes, right? He traveled for 20 minutes, but to do this conversion, the time needs to be in hours. So then we need to convert this. So this is 20 minutes over 1, but then we're going to say times. The conversion from minutes to hours, what? 1 hour corresponds to 60 minutes, right? So this is how we do conversions. You show the units, you put the top unit over the bottom unit, you write everything out like this, and then the whole point is so you can cancel your unit so you can finish in the proper unit, right? So with the written in this fashion, minutes are canceled, they cancel each other. Hours cancel each other, and the only thing that's left is this distance. So then you can just crunch the numbers, right? Okay. So then the top part, we got this 68.75 times 20. Come on. Okay. And then we're going to say all of that divided by 60. 22 point, basically approximately 23 miles. All right. So then this is approximately 23 miles. Okay. Let's see how do we do, and then go back for an assessment. Let's copy. Okay. Oh man, class is almost over, and we still got a ways to go. Let me just kind of keep moving. Okay, 68 3/4 is that what we got? 0.75? Yeah, okay, so we got the same speed. Yeah. We said we rounded, right? We said approximately 23, so this is fine. Yeah, this is fine. Okay. Yeah, we still got a ways to go. And I know there was a request for homework. You're gonna have to make a decision. because I intend to finish this. I'm going to finish the stream. It's probably going to take me longer than 15 minutes. Well, we got 10 slides. It might not. We'll see. If you still have the energy and you're still willing, we can still work through questions. It's, you know, and I feel pretty good. I feel like I have the energy and focus, so we can talk about and go through as many questions as we can. Let me just finish this out. Okay, so then the definition, let f be a continuous function on a closed interval AB, then the moving average function of f is given by this. So moving averages, right? So now given an interval in the previous part, given an interval, we saw how to find the average value, right? With the of that situation. So then the moving average, you have one region, you find the average, then you shift it by some increment of whatever, some increment. Then you find the average of that, then you shift it again. So you're basically having to do it like repeatedly, and so it's a moving average over several intervals or whatever. So let f be a continuous function on a closed interval AB. The moving average function of f is given by the moving average. Let me see. The moving average value of f is given by 1 over L times the integral as x goes from as t goes from x to x plus L of f of t dt, where L is a constant representing a fixed interval of time, right? So we're adjusting it by some fixed interval of time. Let's see this in action. So we have this example 6 on business on moving average. The weekly revenue in thousands of dollars of trucks rental X weeks since the start of the year. For the sake of time, I probably am just going to go ahead and piggyback off of the prepared notes just to kind of wrap it up. Let's see. Since the start of the year is given by this, right? Where X is from 0 to 10. Let me see. The weekly revenue in thousands of dollars of trucks rentals X weeks since the start of the year is given by this, right? Where X goes from 0 to 10 weeks. Find a moving average over 3-week intervals. Okay. So I think we just said the moving average was 1 over L. Let me see, where L is a constant representing a fixed interval of time. So I think the L in this case might be a week. No, 3-week intervals. So then it would be 1 over 3, right? So then the first one would be as if X starts at 0 and then 0 plus 3. So as it's basically going to be 1 over 3 times the integral from 0 to 3 of that function. All right, so you still have to, find the integral. And then, I'm going to piggyback off the prepared notes, right? So again, we said the L is 3, because it said a 3-week interval. To find the moving averages for the first 3 weeks, first we set X equal to 0, all right? So then if we're looking at the moving averages, we let X be 0. So then the L was 3, we're going to get 1/3 times the integral as X goes from 0 to 3 of that function, right? You got to this whole thing over here, right? We're not going to write all of that. You take the integral, you get a result. So you see it here for that one. So then therefore, over the first 3 weeks of the year, trucks rentals had an average revenue of almost $17,000 a week. Man, that's what I'm talking about, okay? So that's the average for the first 3 weeks. Now we want to shift it. Instead of X starting at 0, we're going to have X start at 1. So we're going to look at the average as X goes from the first week to the 4th week, all right? So now the moving average over the second set of 3 weeks as X goes from 1 to 4 is basically repeating the same thing, but now instead of starting at 0, X starts at 1. So we go from 1 to 4. Then you just do everything like before, you get another average. Then instead of starting from week 1, then you're going to start from week 2. You see it here. So 2 to 5, 3 to 6, 4 to 7. And I think you keep going until I think you get to the 10, right? 7 to 10. Right? So then the moving average smooths the data but maintains its general trend. So then the graph below displays R along with the graph of the moving average, our average. So R is the revenue and then the average revenue every 3 weeks over the 7 3-week periods of time. I know that's a little bit weird, but I think you get it. The graph of the moving average retains the general shape of the graph of the revenue, but reduces the fluctuations, making the general trend easier to see. All right, so it's just another representation of our data. Okay. So, thank the Lord for our prepared notes, because that would have been a lot to do like on the spot like that. So we actually finished the time, surprisingly. I didn't think it was going to work. But I think the concept you know, because if you can take intervals, I mean, if you can take the integral, then I feel like you can handle that. You just need to just see the application and the concept. Okay. And so then we have a quick section summary. It says the additive property of definite integrals state that a definite integral can be expressed as the sum of two or more other definite integrals. If f is continuous on the closed interval from a to c, and we choose a b such that b is between the a and c, then the original integral can be broken up into the sum of two other integrals. The area of a region bound by the graph of two functions, f and g, where f is greater than or equal to g on some closed interval. So again, that area between those two functions is going to be given by this. So we saw several examples working that. And I think we got a little bit more. The average value of a continuous function f over a closed interval ab, so the average value is going to be 1 over b minus a times the integral, the regular interval, right? And then let f be a continuous function over a closed interval ab. The moving average of f is given by this guy here, where L is a constant representing a fixed interval of time. All right, I think we hit cap locks, okay. All right, so I think with that, that actually brings us to the end. So we actually that lecture did hit the right mark. I know there was a request from some homework. Did you use the Ask My Instructor? Is it from the homework or a quiz? You guys still there? Yeah, you still there. Testing. I know. Come on, guys. You there? Let me check that. Okay. Yeah, let me check my email real quick to see if I can if you used Ask My Instructor. Give me just a moment. I'm kind of replying to you. If you see this, you should pull up. You should stay in the meeting room and pull up the YouTube, the live YouTube.
Yeah, he said something.
What do you say?
Oh no.
Yeah, you hear?
Said something.
Yeah.
And then he
Yeah,
responded.
I'm here.
Okay, it's okay. Let me see. Give me just a moment. If it's a homework question, you know, go ahead and use the Ask My Instructor. If it's a quiz or an exam, then just let me know. We can pull it up. If you see this, you should stay in the.
I'm about to send it.
Okay. If you see this, you should stay in the waiting room and pull up the live YouTube presentation and wait until.
Professor, I got
Go
something.
ahead.
I got something really important to do, so I'm gonna have to leave.
Yeah, it's fine. Yeah, you don't have to. You don't have to announce it. It's fine. Okay, so just today we did 4-4. I think we have 2 sections remaining, so 4-5 and 4-6, and we'll just be working on those next week. And just kind of keep working through the homework, work together, link up with the tutors. You know, just do what you need to do to kind of process it. Okay. Take care. Have a good weekend.
Mm-hmm.
Yeah. All right.
I sent it. It's the second one I sent.
Okay.
Or the most recent one.
Let's see. Let's see. It says find the area. Yeah, this is what we talked about today, I think. Find the area. No, this isn't today, but let me pull this up. Share. This. Oh, I know another place I can check. I just want to see what section this thing is in. 4.4. That's today's. Okay, that's fine. So find the area of the shaded region. Can we get a better image? Okay, that's fine. It looks like its x goes from -3 to 1. So we might need to break this up into 2. And I want to say the area should be the net of the 2, right? Let me think. That should be a negative result, and that should be a positive result. You add them together. Okay, here. Let's can I move this?
Mine might be a different one.
Is this not the right one? This should be yours.
I sent another one.
This is not this one?
Mm-mm.
Okay, hang on. Let me pull up another one. Let me check one more time. Okay, I see the second one. Let's see. It says find the area. Okay, this is fine. Let me share. Okay, find the area of the shaded region. That's fine. That should be negative, and that should be positive. Let's see something. If I can, it'd be nice if I could just move this around. There we go. That's exactly what I wanted. Can I shrink it? If I can shrink it, that'd be even better. But that's okay, because I want it to be about right there. That's good. Okay, so let me get a copy of this. Yeah, we're gonna take that. Here. I think this is fine. Like it shows us everything that we need. And add a page. Okay. So it says find the area bound by the shaded region. So then we have this f of x equal to 15x minus 2x squared minus x cubed. And then we have g of x. It looks like it's equal to 0. Okay. So I know before we said, like, if you were to find this area, right, this one should give us a negative result. This one should be a positive result. And then if you take the difference, since it looks like we have more of it to be negative, so the overall thing should be negative. Let me think about it. And so basically what we're gonna do, I'm gonna break it up into 2. We're gonna find the area of this first shaded region. We're gonna find the area of the second shaded region. And then either we just add those 2 together or we find their difference, and the difference will be negative, right? But that's the only thing. Let me check one other thing before I do that, so we're not wasting so much time. Do is, if I can get this to behave, I'm gonna you an example. And okay, yeah, f of x minus g of x. Let me see. But you have double pair. Notice that the graphs cross. So one function is not always right. Okay, that's fine. So since the function is cross, find the points where the graph cross, and then yeah, that's fine. Set them equal, blah blah blah, blah blah blah. So we split it into two. So that's fine. So from -3 to 0, and then 0 to 2, and they're adding those two results. Okay, that's all I needed to get to the bottom of. Can you get a negative? Still positive, that's fine. Okay, so let's do that. That's what I had in mind, but I just needed to know should we add or subtract, but they added those two. Right, so the idea is that when we introduce this, like we introduced it where one function was always greater than or equal to the second, but in this case, one function is not always greater than or equal to the second, so we need to break it up into multiple components, right? So we want to find out where these two functions are equal to each other. So let's set them equal to each other and solve. All right. So we're going to say we want to look at when f of x is equal to g of x, right? So then we have this 15x minus 2x squared minus x cubed. We want to set that equal to 0 and solve. I'm going to multiply both sides by a negative to just make it look more simple. So we have this x cubed plus 2x squared minus 15x equal to 0. We can factor out an x from all the terms. That'll leave us with x squared plus 2x minus 15. It looks like this can be factored into something of this form, right? Where we have x and x. It's going to be a plus and a minus, 5 and 3, a positive 5 and a negative 3. This times this is negative 15. 5 plus negative 3 is a positive 2. All right, so then, now that we have three things that multiply to give us 0, you set each factor to 0 and solve. So then we get x equals 0, or x equals negative 5, or x equals 3, okay? So these are the points where the graphs are going to be equal to each other, -5, 0, and 3. So then what we're going to do, we're going to evaluate the integral as x goes from -5 to 0. The one that's on top from -5 to 0 looks like it's g of x, right? So we're going to say g minus f. So we're going to say g of x minus f of x for this one, dx, right? And then we're going to say plus the integral as x goes from 0 to 3. And I think it reverses for the other one because f of x is on top for that. Oh, shyster. 3? Why do we get 3? Oh, that's when they're equal, right? But we're only evaluating as x goes from 0 to 2. So we're not going to do the 3. We're going to go from 0 to 2, right? Because even though they're equal when x is 3, but we're only concerned up to when x is 2, right? So we're really doing from -5 to 2. So then for the second part is from 0 to 2, but then f of x is on top. So we're going to say f of x minus g of x. So for that one, we're going to say f of x minus g of x dx. Okay, I feel like this is what they did. Because when we introduced it, this is how we introduced it, where basically it was the top one minus the bottom one, okay? So let's see. We know g of x is 0. F of x, let's just copy. F of x is all of this. Okay. So now for this first one, this is going to be equal to integral as x goes from -5 to 0. It's going to be 0 minus all of this. And let's go ahead and distribute our negative. All right, we get this dx. And we can get rid of this, right? Because we distributed our negative. We said 0 minus all of that stuff. We get this. Okay, and then for the second one, we're going to say plus the integral is x goes from 0 to 2. So then f of x, which is this, minus 0. So then we're just going to say dx. Okay. So then if we evaluate these integrals, the first one is going to be negative 15 x squared over 2 plus 2x cubed over 3 plus x to the 4 over 4 as x goes from negative 5 to 0. Then the next one, I think it's the same thing. Let's do like this. Negative 15x squared over 2. Wait a minute. It's no negative, right? It's not exactly the same. 15x squared over 2 minus 2x cubed over 3 minus x to the 4 over 4 as x travels from 0 to 2. Come here. Come here. Just lay down right here. I know you see things out there. How dare they get in your field of vision? You know, it's okay. Lay down. Thank you. Okay. Why do you always like need a bath? Like I swear you just got a bath and you smell like you haven't. Come here. Lay down. We're gonna have to work on your mouth. Lay down. You stink. I can smell your mouth all the way up here. Stop yawning. Come here. Lay down. Lay down. Lay down. Because I don't need you in a distraction. Lay down. Okay. So now when x is 0, okay, that's fine. When x is 0, I think all of that collects to 0. We're going to say 0 minus. So we just got to be aware that we're distributing another negative. Let's see. Now we plug in when x is negative 5. So that's going to be negative 15 times 25 over 2 plus it's going to be negative 2 times 125 over 3. Let's see, plus 625 over 4. Okay. Let me think about this. 0 minus that. Okay, so we need to distribute it. That negative is fine. Then we're going to say plus. Now we got to do the second part. So this is really just mostly organization because there's so many like nested intervals and the signs keep flipping. That's the hardest part about this one, right? Let's just keep going. So I feel confident about that first set. Then the second one, now when we plug in that 2, so that's going to be 15 times 4 over 2 minus 8 times 2 is what, 16? 16 over 3 minus 16 over 4, so minus 4. Let me think. That's when we plugged in the 2. Then we got to say when we plug in 0, it all collapses to 0, so we kind of ignore that. All right, so we get this. Okay. Let's see. Let's keep going. Hey Google, what's 15 times 25? 375. Okay, that's fine. Okay, so then we get a positive 375 over 2, 250. So plus 250 over 3 minus 625 over 4. All right, I think we can keep going. Plus 60 over 2, so that's 30 minus 16 over 3 minus 4. Okay, we're just gonna have to go with it, right? Okay, let's keep going. I'm just gonna use the calculator for the rest of it. Let's see, so we got 375 divided by 2 plus 250 over 3 minus 625 over 4 plus 30 minus 16 over 3 minus 4. Okay. let's see. It says type an integer. Let's hop back over here. As a fraction. So it looks like we get 541 over 4. Let's see if we can get that. 541 over 4. Oh no. I mean, we didn't really check anything. I'm trying to think, how could we go back and check? I know if I had a TI-89, I know how to kind of do those. And I think this one can do integration. If I go to calculate the integral, let's try to, let's try to use this to see if we get the same thing. Okay, so let's do something really quickly. So we got an answer. We got 541 over 4, right? So now let's do this. Let's go to y equals. Let's clear this out because this is from something else. So now f of x is what? 15x minus 2x squared minus x to the power of 3. And g of x is 0. Okay. Now I just got to think about the notation. That's the only thing. Let me look that up real quick so we're not wasting too much time. Let's just try our answer because I was gonna crunch it in this. Let me see. I think I can do it. Let me try a couple of times. So for instance, if I go to calculate, no, I'm gonna quit. Darn it. Come on. Okay, let me quit this. If I go to calculate, I want to calculate the integral, right? So 7. That's not what I want. Let me quit this real quick. Here. Okay. What if I go to math? I mean, it could do it. It's just not doing it the way that I want. I know there's a way that it could do it. Let me look around. But since I don't see it immediately, I'm just going to submit the result that we got. And we can still come back and check. Math as a fraction. 541 over 4. Let's try this here. Okay. Let's try 541. Are you not with me? Stuff is so temperamental. 541. Come on. Numlots. Is it? I'm trying to open the corner. Thank you. Come on. That's so strange. My keyboard for some reason doesn't let me type.
The solution, the problem worked.
What happened?
I said the solution worked.
It did work 541 over 4?
Yeah.
Thank you. Because for some reason it wouldn't let me type in. Yeah. Okay. Accessibility. Turn on accessibility if you want to use a screen reader or navigate with a keyboard. Let me turn this on. Maybe that's why it's not working. Okay. Did you have another one or?
Let me check. Actually, we can just, if we have time, we can do this one as well. I don't think I did it right. I just don't have the right calculator put the answer in.
That's weird. So I mean, I found this site called Chemtech. Like what I'm using is it's free. It just takes some finagling to get it working.
Mhm.
This is like basically a emulator that some students at a university created. I've been using it for years. It took me years to find it. They made it, and then I've been using it. But it's cemetech.net. You have to kind of search around. But then the other thing is that you have to download like a ROM. So, and it took me a while to find something that worked. I just had to research, do a quick Google search on how to find a ROM. You can use this GeoGebra. It does graphing, and you can crunch these numbers. It just takes a little bit of getting used to programming that. I know sometimes students use Desmos. I mean, she totally like laid down and went to sleep. It's so funny. She's like stretched out, and then she knows what I'm talking about. It. She like opens her eyes. Got this weird pose. Anyway, yeah. So yeah, but this is free. It just takes effort to get it operational. Yeah. Okay. Did you have another one or? Still there?
Yeah, I just sent one more.
Okay, let's pull it up. Let's see. This comes from section, the same one from today. It says the company determines that its weekly sales in hundreds 2 weeks after. Find the average weekly sales for the first 8 weeks. Oh, this is like that last example that we did, right? So let's pull it up here. Oops, I hit it twice. Let's see. So it says a company determines that its weekly sales in hundreds of dollars, 2 weeks can be estimated by this equation. Find the average weekly sales for the first 8 weeks after online sales began. Let me look at that last example that we asked really quickly. This one says, see, that's moving average, right? So this one says the weekly revenue $1,000 since the start of the year is given by this. Find the see this one says find the moving average. So they just want so we're not doing moving average for this example. Okay. And let's hop back here. So then it says a company determines that the weekly sales, blah, blah, find the average weekly sale for the first 8 weeks. Let me think about it. Yeah, it doesn't say the moving average. So it should be like 1 over, let me just see, can we see if you an example? It should be 1 over B minus A. It should just be the average one, not the moving average. Yeah, you see it here. So 1 over B minus A times the integral as X goes from A to B of f of X dx, right? I think we can take it from there. So I don't know what's going on my keyboard. Like that's irking me. Like I don't understand why it's not working. Can we zoom in? Okay, that works. Let's accessibility. Let's turn this off for right now. No wonder. Nope, not even clicking the right spot. Come on. Okay. So then, yeah, that's a little bit better. No, that's too far. Okay. Let's get a copy of this. Near sent. we're gonna take that. Let's drop it right here. Okay. So right here. So it says a company determines that its weekly online sales in hundreds of dollars 2 weeks after online sales begin can be estimated by this equation. Find the average weekly sales for the first 8 weeks after online sales began. Okay, so notice it did not say moving averages, right? Where's my pen? Oh, no, right there. There it is. Okay. All right. So we are going to be using, let me see, 1 over, let me see. So S of t average is going to be 1 over b minus a times the integral as x goes from a to b, or I guess as t goes from a to b, s of t dt. Okay. So then for hours, we want the first 8 weeks. So we're going to do 1 over, it's basically 8 minus 0. The integral as t goes from 0 to 8 of 2 et dt. Okay. So 1 over 8. Let's see. I don't know why it's being so sensitive. You can essentially move that 2 to the front, right? You know, I think we talked about that. So then you can put the 2 like there. The integral of e to the t is going to be itself. And we want to evaluate this as t goes from 0 to, oh my goodness, it's like, I don't know why other stuff keeps popping up. 0 to 8. Oh, maybe it's this chord. I might have to get rid of that chord. It might be that chord. The chord is like dead. I shouldn't be using the chord. And the thing is, I got a perfectly good chord. I guess I was just using it until it didn't work no more. It might be the chord. Okay. As t goes from 0 to 8. All right. Okay, I feel good about this. So then if you plug in when t is 8, so we're going to get what? 1 over 4 times e to the power of 8 minus e to the power of 0, which is 1, right? And then basically just use a calculator there. So long story short, it should be 1 over 4 times e to the power of 8. Unless we need some parentheses. Insert parentheses. E to the 8 minus 1. Okay. Round to the nearest cent. So 744 and 99 cents. Let's see if this works. $744.99. This one. $744.99. Okay, now it's working. Well, let's see. B minus A, we did that. Let me see something again. The company determines that its weekly online sale in hundreds of dollars, T weeks after online sale begins, estimated by this equation. Find the average weekly sales for the first 8 weeks. Oh, oh, okay, wait. hundreds of dollars, right? Okay, so hundreds. So we need to move the decimal to the right by 2. Let's try moving the decimal to the right by 2. So then 74,500. Okay, hang on. Let's go to view an example. And let's try to figure out what we're doing wrong, what we're missing. I feel like it's something light. Yeah, we did that. It says 6 weeks, right? Keep going. Zoom out. Nearest cent. Oh, that might be why, because that might not be the nearest cent. So if we move the decimal to the right, that's going to be 95 cents. This is going to be our last try. If we get it wrong, then we'll fix it. We'll keep going to get the credit. We said 95 cents, right? Now I was trying to get this thing to work. Come on. Okay. 744. Get it one more time. 98.95. So that needs to be 98.95. $98.95. Okay. Round to the nearest cent. I think this is good. This is our last try. Got it. Right. So what we did was fine. We just had to adjust it. Right. That was the problem. Because the idea was that these calculations were done in hundreds of dollars. So when we got that 744, we had to realize that that was 7,400. So what that means is that we had to move the decimal to the right by 2, and then we had to re-round properly. Right. So what we did, the calculus that we did was fine. We just had to go back and adjust and put the units in their proper form. Hopefully that was okay. It's down to the wire, but we got it at the last second. So testing. Oh, yeah, the oxygen tree. Were you able to see what we did there?
Yeah.
Okay.
I think that's it.
All right. Well, just keep working.
Are we able to
You know how
come
to
back?
find me.
Yeah, are we able to come back
Okay.
Friday if
Yeah.
we need extra help?
Is the school open this Friday? I know we have a Good Friday coming up. I don't know if it's this Friday or next Friday.
I haven't heard anything about no school this Friday.
I think that might be this. It might be next Friday. Let me check. I know we have a holiday one of these Fridays coming up, and it doesn't affect you guys because we only meet on Monday and Wednesday. But if it's a holiday on Friday, that means I wouldn't be meeting with that group. I look at the calendar right here, April 15th. So that's in a couple of weeks. Okay. Yeah. So this Friday should be good.
This Friday we should be good.
Okay. Yeah, I
Is that what you
teach
said?
at 10 and 2. Yeah.
So come at one of those times.
Either like either 10:30 or 2:30 would be ideal to give, because that way you can give the college algebra students a chance to get questions, and then
Okay.
and probably 10:30 is probably better in the morning, because in case we miss each other out for whatever reason, then we can try 2:30.
Okay.
Okay.
Okay. Thank you, Professor.
All right. Yeah, my pleasure. All right. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of the evening.